We can now add our reflection probes. To do this, click the Game Object dropdown and under Lighting, click Reflection Probe. Reflection probes capture a spherical view of its surroundings in all directions. The captured image is then stored as a cube map that can be used by objects with reflective materials. Since the sphere of the reflection probe represents where the reflections are initially cast, we'll need to move it to ensure that it's positioned high enough that it can view all the elements of our scene. We can also offset the position of the reflective casting sphere in comparison to its position with the rest of the box by adjusting its box offset in the inspector. With reflection probes, we have the options to use either a box or spherical reflection. By adjusting the reflection probe's intensity, we can adjust the influence it has on the reflective surfaces in our scene. Next, duplicate the reflection probe and move the duplicate so that it appears higher than the original. Then, adjust the borders. Since there will be moving objects in our scene, and since our lighting is set to both real-time and dynamic, we'll use this duplicate reflection probe to cast real-time reflections. With the duplicate selected, in the inspector, change the type from baked to real-time. In order to have only minimal impact on our game's performance, we need to decrease the resolution of our probe. Change the resolution from 128 to 32. Additionally, we'll also need to adjust our far clipping plane as well as our shadow distance. If we temporarily increase our probe's resolution, we can see exactly how high our far and shadow distance needs to be in order to capture all the reflections of our scene. Lastly, we'll adjust the importance of our baked reflection probe to 2 to ensure its reflections have priority over our real-time reflection probe.